where in the calculus curriculum do we see trig identities used? Now, while we do use trig identities to simplify expressions here and there, our trigonometric identities are also a fundamental part of the integration technique trig substitution. The goal of our integration technique trigonometric substitution, also called trig sub, is that we want to use a trig identity to somehow simplify our expression to make it easier to integrate. What we see is that 4 minus x squared looks a lot like 1 minus x squared, and we know that 1 minus x squared also looks like 1 minus sine squared. Therefore, we'll let x equal sine theta. Now, we leave a placeholder here because we are going to want to adjust the constant. The reason for that is if we just plugged in sine theta here, 4 minus sine squared of theta isn't an identity. So we go ahead and let x equal 2 sine theta. Therefore, 4 minus x squared becomes 4 minus 2 sine, all of that squared, which is 4 minus 4 sine squared. Pull out the 4 from both terms by factoring. We get a 1 minus sine squared. That turns to cosine squared using the Pythagorean identity. Now all we're going to do is substitute our values in. Note that we said x was 2 sine theta. That would also mean if we were to take the derivative, that dx would be 2 cosine theta d theta. We also knew that 4 minus x squared was 4 cosine squared. Take all this, let's plug that in, and we end up with this. What we notice is that the square root of 4 will go to 2, square root of cosine squared will become cosine. We start to simplify. 2 times 2 would be 4, cancels out with that 4 there. These two cosines come together to be a cosine squared. This expression is cotan squared. Now all we have to do is integrate cotan squared. Well, currently we don't have a nice memorization rule for cotan squared, but what we do know is using a Pythagorean identity, 1 plus cotan squared equals cosecant squared, cotan squared of theta is actually equal to cosecant squared of theta minus 1. All we do is move the 1 over. Therefore, integrating this matches an identity, so the derivative of cotan is negative cosecant squared. Therefore, the integral of cosecant squared is negative cotan of theta. We also see 1 just integrates to theta, plus c because we have an indefinite integral. And solving for cotan theta and theta using our original substitutions, this would be our final answer. Notice how in that problem we used a couple different identities along the way to get to our final answer.